In today's session, we shall look into the different types of chemical reactions. This year, you're going to study 5 different types of chemical reactions. They are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation reduction reaction or redox reaction. In today's session, we will study the first 4 different types of chemical reactions. The last one we will do in the next session. First type of reaction is combination reaction. A reaction in which a single product is formed from 2 or more reactants is known as a combination reaction. Example, calcium oxide reacts vigorously with water to produce slaked lime. Calcium hydroxide releases a large CaO plus H2O forms CaOH twice. The first two CaO and H2O are called as reactants. And what is written on the right hand side, CaOH twice, is known as the product. So calcium oxide CaO and H2O are known as reactants. They are written on the left hand side. And calcium hydroxide, which is lakered lime, is written on the right hand side. It is known as the product. So in this reaction, 2 or more, that is here 2 reactants, give rise to one single product. Such a reaction is called as a combination reaction. This is the activity. If you add calcium oxide into water in a beaker, it produces bubbles because of the heat that is released during the reaction, and the beaker becomes hot. This is a combination reaction. Long back ago, the whitewashing material used to be prepared in this fashion, and calcium oxide was obtained from seashells. Seashells used to be just powdered and put in water. It results in the formation of CaOH twice, which is used for whitewashing purpose. Other examples of combination are carbon plus oxygen giving rise to carbon dioxide, formation of water from H2 and O2 giving rise to H2O. The next reaction is decomposition reaction, which is exactly opposite of combination reaction. Look at this reaction, burning of ferrous sulphate. There is a single reactant which in the presence of heat gets decomposed into 3 different products. Fe2O3, which is ferric oxide, SO2 and SO3. This is an example of decomposition reaction, a reaction in which a single reactant breaks down to give simpler products is known as decomposition reaction. Let us take another example. CaCO3 in the presence of heat decomposes to form CaO, quicklime and carbon dioxide. This is an activity showing decomposition of ferrous sulphate to ferric oxide, sulfur dioxide and sulfur trioxide. This is photochemical decomposition where silver chloride AgCl in the presence of sunlight breaks down to form silver and chlorine. It is called as photochemical decomposition because it occurs in the presence of sunlight. We will look into an activity, electrolysis, which is breaking down of H2O into H2 and O2. Electrolysis is Electrochemical decomposition. We'll just look into what is involved in the activity. We have to take a plastic mug, drill two holes at the base to fit a rubber stopper on in these holes. Insert carbon electrodes in the rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. This is to enhance the electrolytic process. Take two test tubes filled with water and invert them over the two electrodes. We will see that there is bubble formation at both the electrodes, and these bubbles are displacing water in the test tubes. Once test tubes are full of the gases, you will find that at cathode the gas found is double the amount the gas found at anode. Why is this so? Because at cathode is formed hydrogen gas, which is two molecules of hydrogen, and at anode the gas formed is oxygen, which is a single molecule of oxygen, because formula stands as H2O. Let us look into another reaction, which is displacement reaction. This also can be studied using an activity. We have to take two iron nails, clean them by rubbing with sandpaper. Take two test tubes marked A and B. In each test tube, take about 10 ml of copper sulfate solution. Tie one nail with a thread and immerse it carefully in the copper sulfate solution in test tube B for 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out iron nail from copper sulfate solution. Compare the intensity of blue color of copper sulfate solution in test tube A. Just have a look at what happens in the test tube. The iron nail that is kept aside is clean, metallic. The iron nail that is coming out of test tube B has got a brown coat of copper on it. And look at the test tubes. Test tube A is blue intense because it is retaining the color of copper sulfate solution. In test tube B, it has turned into dirty green in color. The solution, because the solution has become ferrous sulfate because iron from the iron nail has displaced copper from the copper sulfate solution and converted the solution to ferrous sulfate solution. Such a reaction, in which a more reactive metal displaces a less reactive metal from its salt solution, is known as displacement reaction. The next type of reaction is double displacement reaction. A double displacement reaction is a reaction in which there is exchange of ions between the reactants. Let us look at this reaction making use of an activity. We have to take 3 ml of sodium sulfate solution in a test tube and in another test tube 3 ml of barium chloride solution. Just mix the two solutions. We will find that a white precipitate which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. A reaction in which there is an exchange of ions between the reactants are called as double displacement reaction. You can look at the reaction Na2SO4 sodium sulfate plus BaCl2 barium chloride. It gets converted to BaSO4 barium sulfate and NaCl sodium chloride. You will see that the sulfate has gone to barium and the chloride has come to sodium. So there is exchange of ions between the reactants. Such a reaction is called as a double displacement reaction.